So welcome to another segment of my videos. So today we continue with more concept as we do some more practice questions relating to calculating from a balanced chemical equation. Calculating from a balanced chemical equation. So I'm going to look at a few questions that will help you, to be well, placed to solving such questions when they give you a balanced chemical equation. So like the first one there says a hydrogen bends in oxygen to form water. The equation for the reaction is the one they have given us. So hydrogen, burns in oxygen or reacts with oxygen to produce H2O. Then the question says how much oxygen is needed to burn 1 gram of hydrogen. So the one should to know how much oxygen, in other words, what's the mass of oxygen needed to burn 1 gram of hydrogen. So you go back to your balanced chemical equation they have given you. It is hydrogen reacting with oxygen to produce what we are saying has been H2O or water. So now if you notice what they are talking, the substances they are talking about is hydrogen and oxygen, and therefore your focus as you calculate this one is between hydrogen and oxygen. Now because they are telling you how much oxygen is needed to burn 1 gram of hydrogen, so you can compare the masses, but you can also compare the mole to mole ratio. I'll try to see if I can also teach you if you are able to get that, but I'll simply start by comparing the masses. So if you notice here, the total number of hydrogen atoms is 4, 2 times 2, so it will be 4. It will be 4 multiplied by the atomic mass of hydrogen, which is 1, so that gives me the total mass of hydrogen here. The number of atoms of oxygen there is 2, so it's 2 times the atomic mass for oxygen, which is 16. So 2 times 16 gives me the total mass of oxygen. So this times that is going to give me a 4 grams of hydrogen, produces or reacts, with 2 times 16, that gives me 32 grams of oxygen. So from the balanced chemical equation, it simply tells you that 4 grams of hydrogen reacts with the 32 grams of oxygen. But the question is how much oxygen is needed to burn 1 gram of hydrogen. So what you can do now, you can simply say, suppose now I use 1 gram. Suppose I use 1 gram of hydrogen, then what mass of oxygen? So you don't know, so you replace it by X there. Sorry, I'm changing markers so that you are able to see. From there to find X, you cross multiply. So it will be X times 4. That will give me 4X is equal to 1 times 32 will give me a 32. To find X, I'll simply divide. For what I do this side, I'll do it the other side. This and that will cancel. My X is equal to 4 goes into 32 8 times. So that would be 8 grams of oxygen. So meaning that when you use 1 gram of hydrogen, you need to use 8 grams of oxygen. So this is the way you can calculate, for this, question. Like I said, there's another method. This one that we were using, we can simply call it as being, mass, to mass calculation. Why? Because I'm just comparing the masses. But you can also use what we call as being, the mole ratios. Let me just show you. I'll clean up this one so that I can now try to compare the mole ratio. Again, you need the balanced chemical equation, in order to do that. For example, if I look at this one here, from the balanced chemical equation, what I can simply do, the mole ratio, remember we talked about, are the numbers in front of the formulas, the coefficients in front of the formula. What's the coefficient there? 2. What's the coefficient in front of oxygen? There's a 1 which you cannot see. The coefficient in front of the H2O, there's a 2. So those are the mole ratios we are talking about. So I'll start by comparing the mole ratios. So I'm going to say, in this case, from the mole ratio, here you have got 2 moles. We are going to use them in a short while. 2 moles of hydrogen, and there you have got 1 mole of oxygen. But of course, since the question has given us they used 1 gram of hydrogen, so we need to find the number of moles in 1 gram of hydrogen. Remember, hydrogen is actually diatomic. So the relative molecular mass of hydrogen is actually 2 times 1, which will give you a 2 gram per mole. So you can find the number of moles in that 1 gram. So remember what we said, number of mole is equal to the mass divided by the mixture. In this case, we are talking about the mixture of hydrogen. So the mass is 1 divided by the mixture of hydrogen, which is a 2. 1 divided by 2 give you a 0.5 moles. So these are the number of moles in 1 gram. So what I would do is I can compare now the mole ratio from the balanced chemical equation. So from there, I can see that 2 mole of hydrogen requires how many moles of oxygen? Requires 1 mole of oxygen. Then I'm going to say, suppose I have, remember that 1 gram, we have converted to the number of moles. So I'm going to say, suppose I have 0.5 mole of hydrogen. Then how many moles of oxygen will I need? We'll put up x, then we'll cross multiply. X times 2 give me 2x is equal to 0.5 times 1 will still give me 0.5. To find x, I'll divide to what I do this side, I'll do it the other side. So x is equal to, if you divide using your calculator, that is 0.5 divided by 2. Here it is giving me 0.25 moles of oxygen. So now you have not found the final answer, how much you need the mass. So you can now apply, I'll just write it there. Mass is equal to number of moles times mixture. What's the mixture we are looking about? We are talking about it's for oxygen. So the mass is equal to the number of moles, 0.25 multiplied by the mixture of oxygen. If you calculate just the mixture of oxygen, it's 2 times 16, that gives you 32. So it will be this number I got times 32 there, which is going to give me my mass, which is equal to 8 grams of oxygen. I believe maybe you say the first one is actually much easier for you. Please, you can go for that. I also love it. It is actually more direct, the first one I did. But like I told you, there are so many methods. Let's look at another question that you can basically look at. This one has slightly been erased, but of course it says calculate the mass of calcium chloride produced when 40 grams of calcium carbonate, so that's calcium carbonate, reacts with hydrochloric acid. So they have already given you the balanced chemical equation. So it says calculate the mass of calcium chloride formed. So what do you do? Again, you are interested in calcium carbonate and also calcium chloride. From that balanced chemical equation, you need to find the total mass of calcium carbonate and the total mass of calcium chloride. We know the mixture, if you calculate that one, let me just quickly try to do for both of them. Remember, you have got oxygen, you have got carbon, and you have got calcium. How many oxygens are there? 3 times 16 to give you 48. Carbon, it's 1 times 12, that will give you a 12. Calcium, it's 1 times 40 to give you a 40. If you add all this, that will give you a total mass of 100. You also do the same, the one you are comparing calcium chloride, because the question says calculate the mass of calcium chloride. So they want you to know the mass of calcium chloride formed. So therefore, I'm comparing calcium carbonate to calcium chloride. Let's just quickly find, in this case, the total mass from that balanced chemical equation for calcium chloride. So I've got chlorine and calcium. How many chlorine atoms? There are 2 times 2 times chlorine is simply 35.5. Calcium is 1 times 40. This will give us 40. Of course, 2 times 35.5 times 2, it will give us a 71 here. So when you add 71 plus 40, that will give you 111. So that's the total mass. So now once you find the mixture, you are going to say from this balanced chemical equation, the mass of calcium carbonate is 100. So you are going to say 100 grams of calcium carbonate produces what mass of calcium chloride? It produces 111 grams of calcium chloride. Now, if you remember, the question there said that calculate the mass of calcium chloride. I made a repetition there. So calculate the mass of calcium chloride produced when 40 grams of calcium carbonate react. So meaning, if now we use 40 grams of calcium carbonate, what mass of calcium chloride will be produced? We don't know. Then we are going to cross multiply. This times that will give you 100x, which is equal to 40 multiplied by 111. To find x, I'll divide 100. What I do this side, I'll do it the other side. So this will cancel. X will be equal to, if you use your calculator there, that's a 40 multiplied by 111. What I get divided by 100, that is going to give me 44.4 grams of calcium chloride. So this is the final answer. So meaning, when you use you use 40 grams of calcium carbonate, you need 44.4 grams of calcium oxide. So this is the way you can do it. Thank you so much for paying attention. See you in my next video.